Hello, this is the luckiest maths teacher in the world, and your life is about to change because I'm going to teach you the balance method for solving equations. Now, in yesterday's lesson, we learned how to solve equations using flowcharts. Now I'm going to teach you another method of solving equations. Now, the equations that you can solve today can actually be solved using the flowchart method. But I wanted to give you another way of solving equations. So why would you possibly have to learn two ways? Well, firstly, it gives you more tools to solve equations. You might find that you like this method better. You might find that you like yesterday's method better. But as a maths teacher, I think that the probability that you can solve equations is increased if I give you more tools. The other reason is that throughout your maths career, you're going to have to solve some very complicated equations. Some of them are going to have the x or the y or whatever all over the place. And in that case, you won't be able to use the flowchart method easily. And I'm going to show you examples of that at the end of this video. Okay, so all I want you to be able to do today is to understand the balance method and to be able to solve equations using this method. Now, you need to use equivalent equations, but don't worry, I will go through that for you. Okay, so let's get started. So when we're talking about balance, you might think of, say, a balanced scale. So scales that look like this are balanced, the same amount of weight on each side. Now I'm going to add some fruit to the scales because I know we all love to eat healthy, right, kids? So now we have all these golden apples here. Now clearly they wouldn't balance because there's only 4 on the left-hand side and 10 on the right-hand side. Okay, so what I'm going to do is I'm going to put a box of apples on this scale. Okay, now there are X apples in this box. Remember, I can do that. X just means an unknown number. Okay, so we're going to use the balance method to find out how many apples are in the box. Okay, so we know that these apples weigh the same amount because the scales are balanced and they're all the same size. So what that means is each side is equal, just like an equation. I can write an expression for how many apples are on the left-hand side. So there's X in the box plus 4 more. So X plus 4 apples on the left-hand side. Now on the right-hand side, we can just count them all, there are 10 apples. Now these must be equal. They weigh the same amount. There must be the same number of apples, okay? So I can use these scales to find out very easily how many apples are in the box, okay? So that's why these apples, that's what they have to do with equations, okay? Now I'm all about balance in my life, you know, peace, love, balance, all that stuff. So, to help me solve this, I'm going to take away some apples from both sides of the scales so it's still balanced. So that's what I want. I don't like unbalanced scales. It just throws my world into chaos. I get really annoyed and then I go and do some stupid stuff. Right. So, let's take away an apple from both sides. Okay, so I've rubbed out one of the apples from each side. So now I have X plus 3 equals 9. Okay, these are equivalent equations. So I went through this in the very first video in this module. So two equations are equivalent if they have the same solution, but to find equivalent equations, to find two equations that give you the exact same information, you take one, and as long as you do to the left-hand side what you do to the right-hand side, they will be equivalent, okay? So what we've done here, essentially, is we took this equation, x plus 4 equals 10, right? We took that equation there. And what we did was we subtracted 1 from each side. We took 1 apple from each side. So what I did to the left-hand side, I also did to the right-hand side. Okay, so that means that these two equations here are equivalent. So how does this help me when I'm solving X? Well, what I actually want to do is I want to find out how many apples are in the box marked X. So what I can do is I can take away all the apples on the left-hand side so that there's just an X left. But What I do to the left-hand side, I have to do to the right-hand side. What I do to the left-hand side, I have to do to the right-hand side. So what I'm going to do is I'm going to take away the 3 apples from the left-hand side. So now, on the left-hand side, I just have x, right? But what I've done is a bit of a problem, because these scales will no longer be balanced. If I just take 3 from one side, the scales aren't balanced. So now I'm going to take 3 from the other side. So now that I've done that, the solution is obvious. One box containing x apples weighs as much as 6 apples. These scales are now balanced. So I can just write x equals, and there are 6 apples, right? So if x plus 4 equals 10, x equals 6, okay? Now you probably were like, oh, like I knew that. I could solve that by inspection. I didn't need you to go through it. But there are going to be ones that you can't solve by inspection. So the point is that we're balancing scales, but we're balancing equations by doing the same to the left-hand side as what we did to the right-hand side. So exactly like we did in the flowchart method, we have to undo the operations that have been done to x. So this time, let's say I have 2 boxes with x apples in them, and we have an extra one, and that weighs the same or is equal to 7 apples. So our equation would look like this: 2x plus 1 equals 7. Okay, they weigh the same amounts. There must be the same number of apples on each side of the scale. So we're going to do this similar way to how we just did, but these are called 2-step equations, as you know, because there are 2 steps. So first thing, I want to get all the x's by themselves. I don't want any other apples on that side, because that just makes things a bit complicated. So I'm going to get rid of 1 apple from each side. So what I've done is I've taken away 1 from each side of the equation. So I have 2x equals 6, okay? Now it's easy to solve from here. I have 2 lots of x, and that equals 6. Okay, so what I want to do is I want to find what 1 lot of x is. How much is in just one box marked x? So what I can do is I can divide these into 2 boxes. Okay, so then this x can be that box, and this x can be the same as that box, and we can see clearly that x equals 3. What I've done here is I've divided each side by 2. Okay, so 2x divided by 2, I've cut it into 2, I only have 1 box now. Okay, so I can get rid of this box here and get rid of this box here. And I'm left with x equals 3. That is the solution to the equation, because if I substitute in 3 for x, I get 2 times 3 plus 1. So I'm substituting into this original equation. 2 times 3 plus 1 equals 7. And that's true, because 2 times 3 is 6, plus 1 is 7. All right, let's do some now without the scale. So let's try 4x plus 5 equals 37. So what we do is we do the same thing to each side of the equation. Our goal is to get x by itself. So we do it in the opposite order of BODMAS. So just like we would have done for the flowchart. So the first thing I do is subtract 5, okay? So I undo the addition first, because when I tell the story of x, I do it last, okay? So 4x plus 5 equals 37. If I subtract 5 from each side, I get 4x equals 32. So that's 4 times x, so the way to undo timesing by x is divide. So I'm going to divide each side by 4. 4x divided by 4, the whole reason we did it was to get x by itself, equals 32 divided by 4 is 8. Okay, you can substitute that in and you'll see that's the right equation. Now if you have something like this to do today, let's say 3x plus 2 equals 39, what I want you to do for today is I want you to expand the brackets. I just want you to practice this, because this may end up being much easier for you. Okay, so remember the distributive law. Yes, I know it sucks that you have to remember so much, but we did this in algebra. So what's outside the brackets gets distributed to everything inside the brackets. So this doesn't equal 3x plus 2, it's 3 times x is 3x. Plus, because there was a plus there, 3 times 2 is 6. So I get 3x plus 6 is 39. Okay, and you solve it just like I solved the one up here. So I subtract 6 from both sides, and I get 3x equals 39 minus 6 is 33. Then the last thing I do is divide by 3. So 3x divided by 3 is x, 33 divided by 3 is 11. Alright, let's do another one. X over 5 plus 4 equals, let's say, 8. Okay, so first thing I do is I subtract the 4 from both sides, so I get x over 5 equals 4, and then I've got x divided by 5 equals 4, so to undo divided by, I times. So if I times the left-hand side by, sorry, that should be 5. If I times the left-hand side by 5, I must also times the right-hand side by 5, and I get x equals 4 times 5, which is 20. Okay, so I just want to show you one more example of when the x or y or whatever it is appears in two different places. So I've also put in negative numbers here because there's nothing wrong with having a negative number as a solution. So when you have the a's here, or the x's, the y's, whatever, in two different places, there's no other way around it. Your first step has to be to get all the a's in one spot. So as I said, I want you to expand the brackets when this happens. So I'm just going to leave the 2a alone for now, and I'm going to expand the brackets. Remember, whatever's on the outside, I have to multiply it by everything on the inside. So 4 times a is 4a, 4 times 3 is 12. There was a minus here, so I bring the minus down. Okay, now I haven't done anything to the right-hand side of the equation. So the left-hand side of the equation, I've just made it look different. I haven't actually added to it or subtracted from it. I haven't actually changed it at all. So when you get to this step, you should know how to do this. Remember, like terms. We can add and subtract terms only if they're like terms, and like terms have the same letters. So these two terms are like terms because they both have one letter, and that letter is A, okay? So 2a plus 4a is 6a. Now 6a minus 12, so we didn't do anything with minus 12, it doesn't equal negative 6a. These two terms, 6a and 12, are not like terms. You can't add or subtract them because the 12 doesn't have any letters, okay? Now again, I've just simplified the left-hand side. I haven't added to it, I haven't multiplied to it, so the right-hand side is still the same. Okay, now even though this looks a bit different because it's got negative numbers, we do it the same way. You are allowed to use your calculator. So first thing we do, instead of subtracting 12, we need to do its opposite. We need to add 12. And if we add 12 to the left-hand side, we do also to the right-hand side. So we get 6a minus 30 plus 12 is negative 18. Use your calculator if you're not sure. And then we have 6 times a equals negative 18. So to undo that, we divide each side by 6. So a is negative 18 divided by 6, which is negative 3. A negative divided by a positive is a negative. You can use your calculator. Now, for complicated ones like this, it's a really good idea to substitute in. So if I change a to minus 3, I get 2 times negative 3 plus 4 times, if nothing's written, it's times, negative 3 times negative 3. Okay, so we do brackets first. That equals 2 times negative 3 plus 4 times negative 6. So that equals negative 6 plus 4 times negative 6 is negative 24. And if you put that on your calculator, you do get negative 30. So we are right. Okay, sorry about the length of the video. This has been the luckiest maths teacher in the world. Have a great day.